we draw our perpendicular up to the x. So this is 240, which is fabulous, but I'm really caring about that angle there. So the difference between 180 and 240, we already said, is 60. All right, now I don't know anything else. But conveniently, it's a 60, a 90, and if you want to fill this in too, it's 30. And it is the 30, 60, 90 special ratio relationship that we talked about on Friday. So, who remembers what goes opposite of 30?
1.
1. What goes opposite 60?
Square root of 3.
Square root of 3. And the hypotenuse then is?
2.
2. I'm going to write these in blue because there's lots of black going on. So, 1, square root of 3, 2. If I leave it like that, that is no different than just the right triangle that we could draw in the first quadrant. So, this is where we want to take advantage of the fact that we are in the negative part of the x as well as the negative part of the y. 1 is going to be negative because we're in the negative part of the x-axis, the horizontal leg. Same thing, square root of 3 is going to be negative. And we're going to use our reference angle. Sine is opposite over hypotenuse. So we get negative root 3 over 2. The sine of 240 degrees is negative root 3 over 2. Okay. All right. We're going to transition from SOHCAHTOA to x, y's, and r's. Okay. It's going to be so much nicer if you can embrace our trig function ratios in terms of x, y's, and r's, rather than SOHCAHTOA. Okay, so we got a right triangle. That's x. This is y. And our hypotenuses are, just because we could put this in a circle and it would be, you know, like the radius of the circle is probably the reason why they call it r. All right, so with respect to these three values, we already talked about, and you already used it today, we have a relationship that works between all three, the Pythagorean theorem. Let's put our angle theta here. And now we can kind of cheat a little bit. And sine of the angle is opposite over hypotenuse, so opposite is y over r. Cosine is adjacent over hypotenuse, so it's going to be x over r. Tangent, opposite, oh yeah, this is an A, not an H. Okay, opposite over adjacent, so it's going to be y over x. All right, what's the reciprocal of sine? I forget.
Cosecant.
Cosecant. So cosecant is r over y. Do I have to memorize that? No, I just need to know sine and cosecant are reciprocals of each other. Cosine's reciprocal is?
Secant.
Secant. So the secant of theta is?
R
over x. Tangent of theta, its reciprocal, cotangent, x over y. Okay, so a lot of the logical thought process of the rest of the course can boil down to these relationships. Okay, so we want to get away from SOHCAHTOA and embrace sine is y over r, cosine x over r, tangent y over x, and then the reciprocals. I mean, if you can just remember those, you've got these three all down pat. Okay. As you are working to Okay, you can absolutely draw this, think SOHCAHTOA, and just write this down. If you write this down 15 times in the next, whatever, that would be a great thing. Okay, let's see. Oh, does anybody have any questions so far? Yeah.
Why is the hypotenuse always positive? You can give me a just because it is if you want answer. Okay.
I'm sure there's a better reason just because it is. It kind of would like totally screw everything up. So for example, we are going to determine the quadrant where the sine of theta is, I don't care, greater than or less than 0?
Greater than.
Greater than 0, and where cosine of theta is less than 0. Okay, so I still don't have a great reason. It just always is positive, and we could think of it as the radius of the circle. The negativeness and that kind of stuff is part of the legs, but the hypotenuse is just always positive. Okay. Here, if we think about our grid and our quadrants, remember they go counterclockwise and they start in the upper right. So this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, sine is greater than 0. Sine is positive. If we think about sine, instead of opposite over hypotenuse, if we think y over r, and r is always positive, the value that's going to make the sine ratio either positive or negative is what? Y. So where y is positive, the sine ratio is positive. Sine is positive in quadrants 1 and 2. Where y is negative, sine is negative, quadrant 3 and quadrant 4. So I want sine to be positive. So right here. So that's sine. We want the quadrant. We've narrowed it down to 2 instead of 4. So bonus for us. All right, but we also want cosine to be negative. Cosine is x over r. This can be a little bit more helpful than adjacent over hypotenuse. Again, r is always positive. However, what's going to make sine ratio positive or negative is determined by the x value. So when x is positive, cosine will be positive. Cosine is positive in the first and in the fourth. Any first quadrant angle, the cosine of that angle is positive. Any fourth quadrant angle, 300 degrees, the sine of 300, I don't know what it is. Oh no, I do, it's not special, it is special. It's 300, it's going to be positive. The cosine ratio over in the negative part of the y-axis will be negative. So cosine is negative here and here. So we want both of these to happen, so we're talking about quadrant 2. Quadrant 2. Okay. Ooh, tangent. Where is tangent theta greater than 0? Tangent is y over x. I don't have that whole r benefit. Okay.
Quadrant 1.
So, when will that fraction be positive?
When x and y is both negative and both positive.
If they're both positive, boom. If they're both negative, that ratio is then positive. So first and third. If I wanted to know where is tangent less than 0, so this is here on quadrant 1 and 3. If I wanted tangent of theta less than 0, I'm still thinking about that same ratio y over x, But now, one has to be positive, one has to be negative. So I can have y be positive and x be negative, so that'd be quadrant 2. We could have the reverse. We could have y be negative and x be positive, quadrant 4. Okay. Now, isn't that wonderful? We totally figured out. Does anybody know the cheat sheet thing? Little mnemonic you might have learned in high school? No? Oh, see, then I could just use the one I use all the time. So, there is 2 sayings. All seniors turn crazy. And this actually works for high school seniors or senior seniors. Utah, that's what I learned in high school. Utah High School, they've taught all students, it's a little bit more positive. Students take calculus. Okay, so okay, so are all students turn crazy or are all seniors, students works too, turn crazy? This is going to help you tell which trig function is positive. Okay, so it does go clockwise when you put all seniors turn crazy, just like a positive rotation of the angle. And this is of the main 3. Okay, it doesn't go for secant, cosecant, and cotangent. You're going to have to kind of like rationalize through it. So they are all sine, cosine, tangent, and the secant, cosecant, cotangent are all positive here. Okay, S. Guess which one of sine, cosine, tangent is positive in the second quadrant? Sine is the only one. If sine's positive, what else is positive? Cosecant. Okay, so this is actually using all 3 letters. T. Of the main 3, we're going to talk about tangent. Tangent is the only one that's positive in the third, and thus also, what is positive in the third besides tangent? Cotangent. And crazy, C. Cosine is the only positive one in the 4th quadrant from the main 3, sine, cosine, tangent. So then secant is also positive in the 4th quadrant. Okay, so that's going to be kind of helpful at different points throughout the course. You're going to actually have a question just like this. Figure out what quadrant where sine is positive and cosine is negative, and part of your homework in this section. But we're going to use it all the time. Questions? Okay.